Okay friends, so we have been discussing about the fluid properties. So regarding these fluid properties, already few properties we covered. Next thing we are coming to that specific gravity of the fluids. This is one of the important property. Let us see that the definition of the specific gravity of the fluid. The ratio of the density of liquid to density of water. The ratio of density of liquid to density of water. Liquids may be milk, blood, oils, kerosene, alcohol, cool drinks and etc. So what is reference? So this the specific gravity of any liquid is calculated with reference of the water. So that is what is that pure water. Pure water doesn't have any suspended and dissolved solids, and that water temperature to be considered at 4 degrees centigrade. At 4 degrees centigrade, the pure water is taken as a reference water. Of course, waters, if you take coming to the water, bore water or mineral water or groundwater and sea water, different types of waters are there, but they have some dissolved solids and minerals. So therefore we have to take the reference water, pure water. With this pure water we have to calculate the any liquid specific gravity. So coming to that the specific gravity liquid in terms of the formula, density of liquid, that liquid may be whatever it may be, or milk or blood or oils or kerosene or alcohol or cool drinks, divided by density of the water. So the specific gravity of that the liquid, that liquid density divided by density of water. Okay, so density of liquid, we know that kg per meter cube, density of water kg per meter cube, so that they can get cancelled, units are get cancelled. So specific gravity doesn't have any units, it has a constant value. Of course, this specific gravity we can express in terms of densities or in terms of weight densities. If you see that density means only mass density, please understand. If it is a weight density, particularly we can mention it is a weight density. Otherwise they mentioned in density, that density is nothing but mass density. Density is nothing but mass density. That's why we are getting the units in kg per meter cube. Of course, density of the liquid divided by density of water, or weight density of liquid divided by weight density of water. Again you come to that units, Newton per meter cube. These also Newton per meter cube, they get cancelled, no units. But the thing is that what we have to understand is the specific gravity of liquid or relative density, one and same. Suppose in these two cases, in two formulas, the answer should be same. Answer should not change. Depending on the given data requirement, we have to take either this one or this formula or this formula. So answer should be same. We know that specific gravity of liquid equal to density of liquid divided by density of water. Density of liquid equal to, from this equation, if you know the specific gravity, that specific gravity into weight density of that water, because weight density of water we know that is already, I have a previous video I explained. Density of water equal to 1000 kg per meter cube, kg per meter cube. This value to be remembered. So therefore, if you know the specific gravity of any liquid, that specific gravity into weight mass density of water gives the density of that liquid. In the same way, if you know the specific gravity of that liquid, if you multiplied with the weight density of that weight density of the water, obviously we can get the weight density of that liquid. So therefore no units, it is a constant value of specific gravity of the gas. Of course we are discussing about the liquids, but anyhow I would like to the definition is same, that's why I would like to explain the specific gravity of the gas and specific gravity of the solid. The specific gravity of the gas equal to density of the gas divided by density of the air. So gases, of course the gases may be different gas: carbon dioxide, carbon monoxide, methane gas, nitrogen gas, hydrogen gas, water vapor. These are all the gases. These are all the coming the gases. So if you want to find out that gases specific gravity, the density of that gas, for example, if it is a carbon dioxide, density of the carbon dioxide divided by density of the air. The reference the gas is taking as air. With the air density, we have to compare the any other gases. It may be whatever may be gas, nitrogen gas, hydrogen gas, carbon dioxide, carbon monoxide, methane, all these things we can compare with these density of the air. So the specific gravity of that gas equal to density of that gas divided by density of the air. Again we know that this is the units in kg per meter cube, kg per meter, they get cancelled. Okay. Of course, what is the significance of this specific gravity? Where we have to use this specific gravity? Generally, if you know, we can calculate the specific gravity liquids, solids and gases. So in particularly coming to that liquids and solids, in coming to the particular liquid, so we can find out liquid density, weight density, mass, weight, volume of given fluid. Specific gravity equal to density of liquid divided by density of water. Okay, units same, they get cancelled. So if you know the specific gravity of this liquid, we can calculate that liquid mass density. If you know the specific gravity of that liquid, so that we can calculate density of that liquid, mass density of that liquid, mass of that liquid, weight of that liquid, volume of that liquid, of a given volume of that liquid. All these things we can calculate if you know the specific gravity. Because we know the density of the water. We know the density of the water, that is 1000 kg per meter cube. By using that, we can calculate the required liquid parameters like liquid density, weight density, mass, weight, volume of given fluid. Of course, coming to that another advantage, another applications, specific gravity, manometers and manometer pressure. Suppose if you take any pipeline, we are seeing that the pipe fluid is water is coming from the water tank to the below the floors wherever you want. So through the pipeline, so that what is convey, or otherwise if you take the along the road, there is a water pipeline, through that what is conveying, so that what is conveying with the pressure, with a certain pressure. Unless you maintain that pressure, that water cannot flow through the pipeline. So let us assume the flow is taking place in this direction. By the specific gravity, in the manometer is a device which can use to find out the pressure. If you set up manometer at any point along this length of the pipe, at that point, what is the pressure existed? That pressure can be found out. So during that pressure, to find out the pressure, the specific gravity is a most important. We know the specific gravity. We can calculate the pressure at any point by using this manometer. We can see that when we discussing about the manometers. Okay. You take one just a simple explanation. Specific gravity of milk. Let us take equal to density of milk divided by density of water. Obviously, let us say that density of milk, density, this is a kg, density of the milk, let us say that 1020 kg per meter cube. We know that density of water equal to, obviously we know that 1000 kg per meter cube. So they get cancelled. What is this answer? This is equal to, so therefore 1.02. So what we can understand from this value, 20 kg per meter cube, 20 kg per meter cube greater than the water density 1000. So 20 kg is greater than the density of water, so that so that's why this value get greater than 1. So liquids, this milk, in case water density, already I explained. Water density, any density means kg per meter cube. Kg per meter cube in the sense, this is the volume, of 1 meter. Let us assume 1 meter. This is the 1 meter depth, this is the 1 meter width, this is the 1 meter length. So if you multiply this 1 meter, 1 meter into 1 meter into 1 meter, 1 meter cube. So in this 1 meter cube square box, if you place water in this square box, that box can accommodate only 1000 kgs of water. 1000 kgs of water. So therefore the weight of water 1000 kgs, 1000 kgs of water can be accommodated by this 1 meter cube of volume. So that's why density of water equal to the 1000 divided by 1 meter cube, so that we can get the 1000 kg per meter cube. That is the way we have to calculate the the water density. That is the known value. Remember that, we have to remember that 1000 kg per meter cube. Otherwise, another example, the specific gravity of oil, this is equal to same density of oil divided by density of water. So therefore again, this is the units, kg per meter cube, is the kg per meter cube, so that they get cancelled. If you give the values, so let us say that specific gravity oil equal to let us say that 800 kg per meter cube, water density equal to 1000 kg per meter cube, they get cancelled. This is equal to 0.8. What we can understand here, the density of oil 200 kg of meter cube, 200 kgs of meter cube is less than the density of water. 200, this is 800. So therefore you deduct from this 1000, so 200 kgs of meter cube density is less than the water density. That's why you can get 0.8, or otherwise, in case if you calculated that in percentage, 20% oil density is 20% less than the density of water. So what we can understand here, so that this specific gravity, the specific gravity of the milk is a little bit just, obviously this is just less than 4%, liquids, they can get dissolved in water. You see that, for example, milk, blood, blood, or you take like this cool drinks, alcohol, coconut water, all these things they get dissolved in water. Why? Obviously their specific gravity is little bit just greater than or equal to water density, so that because of that they can get because of that liquids get dissolved in water. That is the reason. Another thing, if you coming to that oils, cooking oil, or you take any oil, kerosene or any oils, petrol or petrol, these things or cooking oil, their density is the specific gravity is less than 1, less than weight density of water. So that what is happening here, if you make this oils dissolved in water, this oil cannot get dissolved in water, dissolved in water, because this weight of that weight density of that oil is less than the water. So obviously that oil is floating on the water. That is the reason. That's why oils they are floating in the water, because that specific gravity or weight density of that oil is less than the weight density of the water. That's why that what is that oil is floating. In case liquids, that any liquid that get dissolved in water, that specific gravity of that milk liquid is just equal to water density. Of course, water density are just 1% or 2% or 3% greater than water density, then only they can get dissolved in the water. Whereas we are coming to that solid stone, if you take any stone, if you throw it in water, obviously that stone is settled down. Why? That stone density is much more greater than the water, much more greater than the water. It may be 2 point something, 2 point something. So if you take for coarse aggregate or fine aggregate sand, 2.6, you can imagine to 2.6. That means that weight density of that stone equal to 2600 kg per meter cube, whereas weight density of water 1000. So that that is much more greater than the water. So that stone is if you throw it in water, that is settle down. That is the reason. Its density is more, or weight density is more, or specific gravity is also more. You can understand that specific gravity is that more, which means density of milk is more, because the specific gravity of the milk or density of the liquid is directly proportional to the density of the milk, density of the liquid. Specific gravity of the liquid equal to directly proportional to the direct density of the liquid. That is the reason. Okay, understand here. So therefore these are the specific gravity, significance and importance. Gravity of seawater equal to density of seawater divided by density of water. So which liquid specific gravity we are going to find out, that is coming here, that is compared with the water. So obviously generally the specific gravity water equal to 1. Of course these specific gravity of the sea water or bore water or municipal water or well water or of course well water, all these things the specific that weight density is almost equal to density of the water. That water we are consider, we know that already this water is pure water, that is to be considered at 4 degrees centigrade temperature. So this is centigrade temperature. So therefore that's why it is of course there is a little bit difference, minor difference. The specific gravity of the water equal to, generally we can take it as a 1. This number you should remember. Why we are getting the 1? This is the almost, this is also almost 1000 divided, this is also 1000. We can get 1. Of course a little bit, very 1000 this 1000 1 kg meter cube or 1000 something something like that, or 1000 0.1 0.1 kg per meter cube, so that it gets something 1.0001. That's why it make it 1. So therefore obviously the specific gravity of the water, it may be sea water or bore water or drinking water, mineral water, the specific gravity equal to 1. So we have to understand, we have to remember that. Another thing, the specific gravity of mercury equal to density of the mercury divided by density of water. So the density of the mercury equal to 13,600 kg per meter cube. That we have to understand. meter cube. Water density, we know that kg per meter cube, they can get cancelled, so that we simplify that one, we can get 13.6. 13.6 specific gravity of the mercury equal to 13.6. What we can understand here? 13.6, so the mercury density is 13.6 times heavier than the water density. That you can understand here in a simple way. If you take a balance here, in this balance you put it to 1 kg mercury, in this pan. This is the center point, in this pan you have to put it 13.6 kg of water, 13.6 kg of water, then only this balance get these pans get balanced. Understand that? This is the meaning of 1 kg of mercury weight is equal to 13.6 kg of water. That much of water is weight is that much of water, kg of water is required to this balance is balanced. So like this, another one, what is the importance of this mercury? Why this mercury is being used in different manometers? So the mercury is using, or at the same time we are experiencing, we are observed many times in thermometer, that is using for measurement of temperature. In that also we can use the mercury. Why you are using this mercury? Mercury boiling point is very high. The boiling point is very high. It is not get easily evaporated. So that's why the mercury is being used in the thermometer or manometers. Mercury is being used. That is the thing we have to understand. So this is about the specific gravity of the fluid and specific gravity of the solids. Solids also compared with the density of the water, and the specific gravity of the we are focused much on specific gravity of the fluids.